I'll start recording. And I checked that the content that so far we have covered that one, that we had a lecture for a certain time period. I think so far we have covered the circuit theory one. I think already you had the examination also. Then under the one module, we have two sections. One is digital electronics section. The other one is analog electronics section. We have covered this digital electronics part. Now we have to complete analog electronics section. Okay. You know that we have covered some topic of digital electronics, but when you come to analog electronics section, it's completely different from what so far we have learned. So the real thing came from this analog electronics section. Then after that, digital electronics section evolved later on. But anyhow, here also we are targeting to learn some kind of basics from analog electronics, not to cover entire thing, the different topics, but the essential things we are going to cover. Okay. At the moment, I think you may have some kind of idea about electronics. It may be analog electronics, it may be digital electronics. So actually, digital electronics, we have discussed certain things so far. In addition to that, some of you may be aware of these topics, and some of you might have the practical experiences also to build circuits, to design circuits like that. Okay. Then anyway, it doesn't matter whatever the experiences you are having. We are starting from zero. Then sorry, that any of you that who could not have that previous experiences with any of these parts, it doesn't matter. Okay, you have my word, then it doesn't matter. We are starting from very beginning, and we discuss all the things, and until you realize everything to a certain level, to face your examination also, to understand the basic, and whatever the thing we have discussed in the class will come to the examination, nothing else. I think we are not going to discuss about that how to make PN junctions, but anyway, we are starting from PN junctions. You know that we can make PN junction. Why do we call this as PN junction? Because we can make a PN junction. We can make a PN junction. That once that you have P-type and N-type semiconductor here, and we can combine these two like this, then you know that better than me about these type of things, and you know that the different elements and all these things, and the different element belongs to different groups also. I think you are well aware about all these things, but anyway, that after taking some kind of basic elements, and after doping certain some other elements with this one, we can make p-type semiconductor and n-type semiconductor. If you want details, I can discuss this one later. But for the moment, assume that p-type semiconductor is there. Then if you consider p-type semiconductor, if this is p-type semiconductor, we have two type of carriers here. When you consider pure semiconductor, let's take this as pure semiconductor. Then with pure semiconductors, there is no thing like that majority carriers. All the positive carriers and negative carriers are equally we are having that. When you have that positive carriers, for that positive carriers, but when you make a p-type semiconductor, the positive carriers that generally we say holes, but anyway that we can put the positive signs here. The positive carriers may be the majority carriers. But it doesn't say there is no minority carriers. Actually, minority carriers are there. But amount is very less. It may be couple of minus carriers we can find here and there. Then here majority carriers, are holes, minority carriers are electrons. Okay, then when you consider the other one, n-type semiconductor, if this is n-type semiconductor, then minority carriers will be holes here, but majority carriers will be electrons. Okay, but here also we can find some minority carriers and majority carriers also. Here, majority carriers are electrons here, and minority carriers are holes, maybe positive carriers. Okay, now this is the situation with p-type and n-type semiconductor. Having with all the characteristics with p-type and n-type semiconductors there, then we can combine these two together. Okay, when you combine these two together, what will happen? Then here we can find that all the positive carriers are here. Like that, then negative carriers like that. But you know that then that because of their mobility, then with this barrier, they can see that with this at this junction, then the p-type semiconductors are having more holes, more positive charges, and n-type semiconductors are having more negative charges. Then very much close to this junction, okay, they can go in each direction, the other direction, and they can get neutralized here. Okay, then this one can travel here. And then after getting this one, initially, what do we have here? This is the initial setup. Then after combining these one, this nearby carriers are going to the other side, then they will get neutralized. Then after that, okay, I have to draw it again. Sometimes these are not working. Anyway. Okay. Okay. After going through the board, then here we can find there is a region created which majority carriers are not there. Okay. Then majority carriers are not there. Then because of that, majority carriers are not there because they are having more mobility that they can go to the other side, then they can get neutralized. Then after that, the region is created. The region is created very much close that around this, what do you call this? Around this junction, that this region is created. In this region, then we don't have the either holes or electrons as a majority carriers. Okay, then because of this one, then actually that this here we have certain region, certain gap between this one. Then this electron is not having much more energy, much more energy to go to the other side because of this distance. Okay, then originally when we create a PN junction, and this is the thing happen around the junction, and after that we can have a region like this, and we call this region as depletion layer. Depression layer. Okay. Then, because of this depression layer, no more electrons or no more holes can go to the other side, and then this traveling of these the carriers are stopped here because of this depression layer. That is the situation when we combine this p-type and n-type semiconductor together. Then for this one, we can have a symbol, not this one, like this, and this is p-type, p side, and this is n side. So this symbol shows that this current can go to the other side, but here we have a barrier like this. This is the meaning of this symbol. But anyway, that instead of this p-n junction and this p-type semiconductor and n-type semiconductor, draw it like this. Then hereafter we use this p-n junction with this symbol. Okay. The simple idea is here in this arrow shows that the current can go one direction, but it has stopped with a certain kind of barrier. Okay, actually that barrier is this depletion layer. Now this is the formation of the p-n junction, and different materials we can use to make these p-type semiconductors and n-type semiconductors. And I'll give you a small note to cover that one. I think it's not necessary to waste your time to discuss those things. These are not a big thing that we can very easily understand in your case, that you know about all these elements, and it is not necessary to spend much more time here. Then after coming to this p-n junction here, you know the characteristics of, actually you know the formation of this one. Then we can work with this p-n junction, actually this device, and we can understand how to use these devices for various applications, for various occasions. Okay. In this case, after making this one, this is, we can say this is p-n junction diode, or maybe you can directly say this is diode, and different name you can find. This is rectifiers, like that. We can use a different name for this one, but diode is a common name. Okay. Then this diode will become, according to the application, according to the place we are using, we can give a different names for this diode, and we will have different diodes also. But for the moment, we can say this is a diode. Okay, now shall we try to understand and how we can use this diode in various applications. Okay. First of all, that we have to understand that how can we send a current through this device? How can we apply voltage across this device? Because whatever the thing that you can understand here, that whatever the component or whatever the device we are using in electronics, and we are applying currents and voltages to these devices. If you know that when you find a certain component, and if you know that when you apply a current or voltage to that component, how that component is behaving, the simple meaning is you know about that component. Okay, whatever the device or component, That is the simple thing you have to understand. That understanding fundamentals means that is that. Okay, I'm telling it again that you can find that whatever the component in electronics, may be device, it may be component, whatever the thing. But if you know how these devices or modules or the component is working against the voltage or against the current, and when you apply current, when you apply voltage, if you know that how these components or devices are behaving, the simple meaning is you know everything about those devices. Okay. That's what we are going to do here. This is a one component and one device we have developed, and we should know how to operate this. How to operate means, what does it mean? How to operate? How can we operate components? To take the functionality of this component, you have to put those components into circuit. When you put those components in a circuit, then the voltage or current or maybe those things will be applied on the component. Then the component is start giving its characteristic or its functionality to the circuit. That's what they can do. Then before we make a circuit combining lot of components together, we should know each and every component characteristics and their functionality against the voltages and current. That's what here we are going to do. Okay, now we have this diode. Now we have diode. Then the important thing, you can apply voltage to this diode. Then we have to find how it is going to be. And the same way, we can apply certain current here. Okay, we can apply certain voltage here across the terminal. We can apply voltage. Then we should know how it is behaving. And after that, you can apply a current. The current will go through it. Then you should know how it is behaving. Okay. Okay. Shall we try to understand these things? And we can apply a certain voltage. Now this is our diode. We can apply a voltage here. And for the moment, I'll put this resistor here, because normally that I have seen that lot of textbooks and lot of places that they are drawing this device with the diode and this battery directly connecting like this. But in practical situation, we can't do like. Because of that, I am putting this resistor to have a complete circuit. But don't think about this one. Don't worry about this resistor. Please pay your attention to this diode and this voltage source. Here we have applied battery voltage here. This is the positive side and this is negative side of battery. And this is P-type semiconductor, I mean N-type semiconductor junction here. Then you know that this is the positive side of the diode and this is the negative side of the diode. Because of that, we can say this is positive side, this is negative side. Okay, this is the way we can connect this one. Now we have to observe what will happen in the circuit. If you connect like this, if we connect like this, battery is connected to the positive terminal of the diode, the battery negative terminal has been connected to the negative terminal of the diode. If we connect like this, then what will happen? Okay, then I have turned on your chat. Then you can, if you want, you can ask direct question, or you can type certain things on the chat. Okay, actually here, this positive terminal of this voltage source means that the positive of this battery means, then from this end you have then current is ready to go from this direction. But then this positive charge will come to this end because battery terminal is connected to this side. Then this is the diode positive side and this is the battery positive side. Then what will happen? Okay, now we can bring this figure there. Okay, now this is the actual situation here. Now what we have done is that we have connected our battery like this. Small resistor, just forget about this one. And this is the voltage source. Then this is the positive side of the voltage source and this is negative side. Now here, from this side, what is available to this terminal? The positive charges. The positive charges are coming from the battery and it will gather here. Okay. Then what will happen? Here we have positive charges. Why this positive side of the battery? Here we have negative charges. Then because of these negative charges and these negative charges, what do you think about that negative charges? Do they like to join? No, they don't like. Okay. They are not attractive because of that they are repelling this. Then, then these positive charges, the strength of these positive charges, because if you have some kind of positive charges, these positive charges, that nearby positive charges will go away to the inside of the PN junction. Okay, then these positive charges get pushed towards the depletion. Why? Here we have positive charges. Because of this positiveness, other positive charges, they don't like to join with them, then they are going back. Going back means they are going inward. Because of these negative charges also. Okay. Here we have this. They don't like to join with each other, then they are going back. So going back means going inward. Because of that, little by little, you can see this pressure is coming from this side. Pressure is coming from this side. And pressure is coming from this side also. Okay. Then at the moment, then assume that this voltage is V1. Okay. And if it is possible to increase this voltage, assume that here we have variable voltage source, then we can increase the voltage value. Then after that, what we can do, here we can increase this voltage to certain level in which V2 is greater than V1. Now, because of that, now more positive charges are here, more negative charges are here, like that. Then what will happen? Then this depletion layer will be narrow. And this force, here we have much more force. Because of that, this force, the depression layer, the width of the depression layer will be reduced. Okay. Next time, what we can do, we can increase this voltage again here. It will be V3. Then V3 is greater than V2 and V1. And because as a result, what we'll have that we have much more pressure here. More pressure here. And because of that, this depletion layer, the width of this depletion layer going to be 0. Then if it is 0, what can we observe here? Now here these are positive charges, these are negative charges. Then they can go across the border. Then if they go across the border here, that more positive charges are here, more positive charges, and more negative charges are around this wire. Then because of that, these positive charges can go across this side. Then this can go to the other side. This can go to the other side. Then as a result, what can you observe in the external circuit? You can observe here, current is generated. Why? These charges are going here to here. And these negative charges can come here, these positive charges can come here, and they will destroy this depletion layer, and then across the barrier, across the border, the charges can be travel. Okay. As a result, what will happen after coming to this V3? After coming to this V3, okay. After V3, I external current can be observed. Okay, but at V1, when you have the voltage V1, can we see the current? No. At V2, we have increased the applied voltage V up to V2, but still we can't observe the current in the external path. Okay, but after increasing the voltage to a certain level, it may be V3, we'll find that figure later. But when you increase this one, then you can see the external current will be there. Okay. Okay, now how can we figure out this one? How can we say this one? Is it okay that did you understand this? Diriti, that I am saying this one as external current because that this battery we have connected external to the PN junction. Because PN junction internally that you can see that certain carriers are going across the border. Actually, inside thing we can't see, but whatever the thing that when you have a practical circuit, whatever the thing we can find and measure all these things external. In the external component, through the component you can apply, you can send a certain current, but externally you can measure the current. But inside we don't know what will happen, but we can explain that one. But anyway, that we have connected this battery externally and we can observe, we can measure the current externally. And this I is external current. That's why I'm saying this I is external current. Okay. Then, okay. Now, how can we tell this story? How can we summarize this story? That we have applied certain voltage across this PN junction. Then inside the PN junction, we observed initially there is a depletion layer. And after applying this voltage, you can see because of the depletion layer, then carriers cannot go to the other side of the junction. But when you increase voltage little by little, the applied pressure because of the carriers, because of the barriers, the applied pressure across the depletion layer will be getting high. Because of that, after increasing the voltage to a certain level, this depletion layer will be zero. Then there is no barrier after that. Then charges can freely go to the other side of the junction. Okay. This is the story. How can we summarize this one in a different manner? How can we summarize this one in a meaningful manner? What about that? This way. Now, across the diode, we have this voltage. Now, we are going to apply this voltage across the diode. Then, as a result, the current should be there. Then we can try to measure this current. Okay. Here we have applied this voltage and we can measure this current. That's what we can do. We can measure the voltage and we can measure the current of the path. Otherwise, that we can't go inside the diode and we cannot see what is happening inside. Only the thing we can measure, we can do the external things we can measure, external things we can observe. Now, we are starting to apply voltage here. Okay, from 0 volt, where we are trying to apply certain voltage. Now we are applying voltage. But initially, until we come to V1, we can increase the voltage to 0.1, 0.2 volts, 0.3 volts like that. But we cannot see external path current. Still, external current is 0. But after applying certain voltage, now you can see, okay, now current is start. We can see the current. But again, we can apply certain voltage. Now, as a result, current will be rapidly increased. Okay. You may ask that how do we know that it's rapidly increasing like that? But anyway, that this is the characteristic curve of the diode. Okay. Then when you apply this voltage, after this voltage, this diode is across the diode, current is going through it. Okay. Then we say this is VF, the forward voltage. Then after that, with this small amount of voltage change, current is rapidly increasing. Okay. Then if you actually apply this one in a lab, the diode will be destroyed. To avoid that, the damage to the diode, that's why I'm putting this resistor. It's a practical way of this one. But anyway, that all the circuits that I have seen, that they are directly drawing these diagrams. This voltage source is directly connected to the battery, to the diode. But it doesn't matter that you include this diode resistor or not, it doesn't matter. But don't think about this resistor, why we have included that there may be some kind of voltage drop across this one, like those problems will come. But anyway, don't think about this. Then this is the characteristic curve of a diode. When you apply this voltage this way, positive to positive, negative to negative. When you apply this positive to positive, negative to negative, we say a specific word here. We say this diode is forward bias. This forward bias. When you forward bias this one, when you forward bias this one, forward bias means when you apply a voltage source, positive terminal to positive terminal of the diode, negative terminal of the diode, then you can see that current is going through the circuit. Now, shall we try to do the other way? What will happen? You have the diode in same direction now, but you have applied this time the voltage in other direction. Now this is the positive side of the battery. This is the negative side of the battery. This is positive side of the diode, negative side of the diode. Then we can increase the voltage. This time also we can take the variable voltage source. You can change the voltage value here. Now you can observe what will happen to this. Okay. We can copy this diagram here. Okay, I don't know if it's possible to delete this. Okay, now this is the way we have applied voltage and we can vary it. This is negative side, this is positive side. And because of this negative side and the negative charges will be there. Then here we have positive charges. Now, because of these negative charges are here at the positive terminal of the PN junction, this negative positive attraction is here. This negative positive attraction is here. Because of that, what will happen? What will happen to this depression layer? All these charges, all these majority carriers will be attracted towards the terminal. Here, all these negative charges, the majority carriers, will be attracted to the terminal side, then positive side. Then, as a result, this depletion layer will be, the width of the depletion layer will be increased. Okay. If you say this is V1, then this depletion layer will be increased. When the depletion layer is increasing means then there is no path. It's not possible to go these charges across the barrier, across the board, across the junction. There is no crossing of the charges. If there is no crossing of the charges across the barrier means there is no external path current. Here, the external path current is 0. Okay. Then what will happen that if we increase more voltage here? Then if you increase more, then it will be V2. Then V2 is higher than V1. Then here you can see more charges will be accumulated. Like that. Then as a result, this depletion layer in previous case, the depletion layer has been widened. And this time also, this depletion layer has been widened here. And because of that, you can see there is no current in external path. Then how can we draw this up? Here. Now we apply voltage in negative direction, the reverse direction. Because of that, you can see there is no current. In previous case, you see that when you apply this voltage here, it will be increased like this. This is for the forward bias the diode. Now here we have applied the voltage in negative terminal, positive side of the battery, and for the positive terminal of the diode, negative side of the battery. Then when you do this one, we say this is reverse bias. When you reverse bias the diode, there is no external current. There is no current going through the device. Then this is the reverse bias side of the battery, the diode, and the reverse bias side, the current is 0. When you forward bias the diode, you can see current is going through the diode. And this is the characteristic curves of the diode, IV curve of the diode. And this is the only operation you have to understand with diodes. If you know about this one, if you have realized these actions, if you have realized these operations, when you apply voltage in forward bias direction and reverse bias direction, that's what you have to learn. And hereafter, all the things you can understand if you understand this one really well. Are you okay with this? If you summarize this one, when you forward bias, the diode, then current going through the external path. You reverse bias the diode. Yes, I see. But actually it's not 0. There is a reverse current, but there is a leakage current here, but we are not going to talk about all these things. In actual situation, there is a leakage current. It's in nanoampere, picoampere range. But we don't consider here those things. It's a negligible things. But sometimes we have to consider those things also. But in your case, in your scope, we are not going to discuss those things. How these reverse currents are possible? Here, we forgot about one thing. And when you neutralize these nearby charges, you may remember these are majority carriers. But then we forget about minority carriers. Here, when you don't have majority carriers here, this side we have negative charges, this side we have positive charges. These negative positive charges can go across the barrier, across the border, across the depletion layer. It will create a tiny current. But we don't talk about those things at the moment. What you want to do, you want to understand when you forward bias a diode, how this diode is behaving, and when you reverse bias a diode, how it reacts to the voltage and what will happen to the current. Those are the things you have to understand. If you know about all these things, now we can start learning diode applications. Anything, any question? Okay. If you don't have anything, shall we start understanding diode applications and how can we apply diodes to the circuit? These are diode applications. Actually, what we have observed that when you forward bias a diode, after certain voltage, we can see there is a current. And when you increase this current to certain amount, the current will be rapidly increased. When the reverse bias voltage is applied to the diode, we can't see any current in the external part. But what is that voltage here? You can see until a certain voltage, this one, there is no current. But what is this? In a value, as a value, VF, this will be 0.7 volts for silicon diodes. You have to apply this, you have to increase this voltage up to 0.7 volts. Then after 0.7 volts, then the diode will be then start conducting current. Start conducting, the current can go through it. Then this depletion layer will be vanished, and then positive current is possible. Positive current is possible. Okay. Then that voltage is you have to apply pressure. Because applying pressure means you need some kind of energy to do that one. Then that energy will be taken by giving this 0.7 volt. You have to provide this energy. That energy is taken by the diode from this 0.7 volt. Then VF will be, it's 0.3 to 0.5 volts for germanium diodes. Normally we say it's 0.3. But with some data sheets, it may be 0.3 to 0.5. Okay. Then shall we take the silicon diodes and we can consider when you apply 0.7 volts, then current is starting to go to the other side. But you can't increase this 0.7 volt when you have the 0.7 volts to 0.8 volts. In between that one, the diode is fully conducting. Okay, we can't increase much more voltages. Then if you are going to increase that one, you have to include certain other components to handle that voltage. Otherwise, diode will be damaged. Okay. Then if you consider this diode, then first application is as a switch. You can use this as a switch. How? The simple meaning of a switch is that you have a battery, something like this. Then you have a switch like this, and we have connected a small bulb here. Then, okay, then this is the switch. When you close this switch, then current will be there and bulb will be turned on. And when you open the switch, there is no current, then path is disconnected, current is not going, the voltage is not applied to the bulb, then it cannot turn on. But the same situation, the same thing we can do adding a diode here. Then with this arrangement, current is there, then this bulb can turn on. Okay. You can see this through this diode voltage, the current is going through, the diode is forward biased. Okay, what will happen the other way? We can take a same battery. This voltage is V, here voltage is V, and we have this bulb is connected to the circuit, and we'll connect this diode in the other way. Then what happens? Then this diode is reverse biased. Because of this reverse bias diode, there is no current. Okay, then we cannot turn on this light. Okay. You understand this? And what are the practical applications of these things? For example, think like this. Okay, assume that you have a small circuit here, small circuit, for example, some kind of electronic circuit. You have some kind of electronic circuit here. This is electronic circuit, and you have to provide positive and negative voltage here. This is the 0 volts terminal, and this is the positive volt terminal. Okay, this may be a small pocket radio. This may be some kind of small electronic light circuit, and this may be electronic organ. This may be electronic, whatever the toy or whatever the electronic circuit it may be. This sometimes your laptop, because that with the laptop for that kind of things that you are not providing voltages like this, that you have specific adapter there. Because of that, it's not practical. But anyway, that you have small pocket radio, you have small kind of cassette. These days we don't have cassettes. But anyway, that any kind of electronic circuit may be that two terminals are there to provide external voltage. Then you can take a voltage source here. You can take a battery here. And with this battery, this is the positive terminal and this is the negative terminal. And you are taking some wires and you are connecting this one to this way. If you do like that, then this is the voltage of this battery and this is correct. No harm. Circuit will not be damaged. But because of any problem, because of some kind of that mistake, you are interchanging this polarity. Okay, you will interchange this polarity, then you will apply this positive terminal to this 0 volts terminal and this minus terminal to the positive volt. Then you are reversing the voltage, then your electronic circuit will be damaged. Okay. For example, I'll do that one also. I'll draw that one also. Then. Okay. And you have connected this. And this is wrong. Then your component electronic circuit will be damaged. Okay. This will be burned. Okay, then how can we find a solution using this one? Okay. Then what you can simply do is, before you apply this one, before you do this one, then you can put a you can fix a diode here as a permanent element to electronic circuit. Then you have this additional circuitry here. You have this additional part here. Now you can allow whatever the person to connect these devices to the voltage. Then if you connect this one correctly, if you connect this one correctly, there is no harm. Circuit will be working. But if you reverse the polarity, again the current is not going to the electronic circuit and there is no harm. Why? Because the voltage is not applied, current is not going inside. Then if you do like this, what will happen? Then the current is okay. Then current is having some kind of value. Then this is here also. The current can go. Here also current can go, creating the same situation. But only the thing, here across the diode, 0.7 volt will be dropped. Otherwise, there is no problem. Then this is the application. You can use this diode as a switch. When you have the correct polarity, it will be working. If you don't have correct polarity, it will be stopped. Okay, this is the way that we can use this diode as a switch. Any problem? But all these voltages we have applied here, they're DC voltages. Here, this is a DC battery. Then we have applied DC voltage to this side. Here, we applied the voltage in reverse direction, but again DC voltage. All these are DC voltages. But what is our requirement to forward bias this diode? We want to apply positive voltage to positive terminal, negative voltage to negative terminal, and we have to increase that one to break the depletion layer. If the voltage is sufficient to break the depletion layer, the forward current will be possible. Forward current will be possible. Forward current is there. But for the reverse bias direction, and when you apply positive terminal to the negative terminal of the battery, and the other way, the current is not going through the diode. And this is the graph of both sides. Okay. Now what happened that if you apply AC voltages to this diode, for example, we can apply AC voltages. Now the diode is here. When you apply 0.7 volts, okay, for the moment that 0.7 volt to this diode, this side, what will be the voltage value? To this terminal, you apply 0.7 volts to this point. Then from this point, what is the voltage we can see? Because we have applied positive voltage to the positive terminal, then this diode will be forward biased. Then when you forward bias this diode, across the diode, how many voltage drop will be there? 0.7 volt voltage drop will be there across the diode. Then the other side, we will have 7 minus 0.7. This side, 6.3 volts. Altogether 6.3 plus 0.7 is 7. This side is balanced. We applied 0.7. 0.7 will be dropped across the diode. Then other side we will receive 6.3 volts. Okay. Then can you answer these questions? Then when you apply plus 10 volts to this one, what will be the other side voltage? And B plus 6 volts. What is the other side voltage? And here C, when you apply minus 3 volts, what is this side voltage? It's D. When you apply 1 volts plus 1 volts, what is here? And E, when you apply plus 0.9 voltage, what is here? This is the input voltage. And what is the output voltage here? This is the input. What is the voltage you can find other side? And here you can apply minus 1.3 volts. Then this side, what is the voltage? Can you write down those things there on the chat? What are the answers you have received? The first one, 9.3 is okay. 9.3 is correct. The vision is correct. And then it's 9.3, 5.3, 0, 0.3 volts, 0.2 volts, 0 volts. Yes. Yes, in this situation, that will be forward bias, then 0.7 voltage drop will be there. Then the resultant voltage will be 9.3 volts plus. Here, diode will be forward biased. Then we have 0.7 volts drop. Then output voltage will be 5.3. Here, when you apply negative voltage, diode will be reverse bias. Okay. Actually, we can't see what other side voltage is, but for the moment we say 0 volts because we don't know the other side of the circuit. Anyway, that some different voltages may be there, but anyhow that through the diode, nothing will be coming to the other side. Here, 1 volts, this is forward bias diode, and 0.7 will be dropped. Then plus 0.3 volts will be there. Okay. Here, this is forward bias diode, and 0.7 will be used to break the depletion layer. Then after that, 0.2 volt will be there. This is reverse biased, and this side you can take 0 volts. Then Malindi, that you have different voltages mentioned in the other side when it's in negative voltages. It's true that sometimes the different voltages may be there, but without knowing the other side voltage, we can't say that for the moment that your answer may be correct. But otherwise, the other side of the circuit we don't know. Then because of that, one simple thing we can say, nothing coming from the diode. From the diode, from this side, the other side, nothing coming. Nothing going to the other side. Because of that, we can say 0, but it's not exactly correct answer without knowing the other side of the circuit. Because of that, you have mentioned some minus voltages. You can take it as correct, but for the moment, I think it's better you have 0 volts other side, assuming that there is no connection to the other side of the diode. If you have some kind of connection to the other side of the diode to the circuit, then you may have a different voltage. Others don't think about this value because I am answering the answers of Malinti's answers. Malinti has mentioned something else. Okay, then shall we start drawing the voltages actually that after applying certain voltages here, now I can draw the circuit. Now here we have a resistor and we are applying some voltages across these terminals. This is diode and this is R resistor. And these voltages are, there is the input voltages I can see, and across this VR. Okay, when you apply voltages like this, this is the time, this is the voltage. Okay. So this is V in, I say. This V in may be this one. Okay, it may be, shall we say, 4.0 volts. Then VR may be then this is VR. It may be 3.3 volts. 0.7 volts dropped across the diode. Here, across the diode, we have 0.7 volts drop. Then VR plus this voltage for drop will be the input voltage. Okay, what about that if you apply this type of voltage to be in? Now this is V in voltage. How can we draw the output voltage? V out. What is V out? What is VR? Okay, it will be something like 0.7 volts less than this. Is it okay? If you are okay with this, Ajay, here that if you are okay with this diagram, this one, then you apply 10 volts, output will be 9.3 volts. Why? 0.7 volt will be used to break the depletion line. Then we will receive whatever the output voltage is input voltage less than 0.7 volts. Then 10 volts minus 0.7, 9.3 is the output. 6 minus 7, 4.7, 5.3 is the output. Here also you can experience the same thing. We apply V as V in 4 volts, but we received as VR output voltage 3.3, 4 minus 0.7. The same thing here. We applied 5, then we received 4.3 during this part. Here it's coming down. Then after that we apply 2 volts. When we apply 2 volts, 0.7 will be used to break the depletion. Then 1.3 is remaining. Diniti, yes, we assume this as silicon diode, but throughout the course that we assume silicon diodes. But if you want to use germanium diodes, you can put, instead of 0.7, you can put 0.3. Okay, now let's think about this one. Now we apply voltage, something like this. Now this is plus 6 volts. This is minus 2 volts. And this is V in. Then what about output voltage? It will be 0.7 volts less input voltage. Then this will be point plus 5.3 volts. And it's coming like this. And after 0, what do you like? This negative side? No, it's 0. And here it can go like this. Then 5.3. And this is VR. Because when the voltage is negative voltage is applied, the diode will be reverse biased. Then there is no voltage or current going through it. Then other side voltage is 0. It's okay. Then if you are okay with that, then think about this one. This is V in, then draw VR. Okay, think about this one. When you come next day, try to draw this one. Anything? Any question? Is it okay? These diagrams? Okay, just think about that, how to draw this output waveforms of this one. When you give this one, then the shape may be a little bit different, but you can see that all the positive peaks are at +6 volts, all the negative peaks are at -6 volts. Then try to draw the output waveform. Next day we can discuss this one in detail. If you don't have any kind of problem, now we can stop the class. Thank you very much for your time. Thank you very much for participation. Okay, we'll meet next day. Until that, Be safe.
Thank you, sir.
Okay, thank you very much.